So in our last lesson, we reviewed the concept of all-star trig class, which helps us to remember the signs of each trig function. So we start in quadrant 1, and we go in a counterclockwise direction. And what these letters help us to remember are what functions are positive in each of those quadrants, right? So A stands for all. So all of the trig functions are positive. So that includes sine, cosine, tangent. S stands for just sine of theta is positive. T is for tangent. Tangent theta is positive. And C is for cosine. Cosine theta is positive. Right? And just to review our quadrant numbers, right? So this is quadrant 1. This is quadrant 2. This right here is quadrant 3. And quadrant 4. Right? So we're actually going to be adding to this because there are 3 other trig functions, and these are the reciprocal trig functions for sine, for cosine, and for tangent. So the reciprocal trig function for sine is the cosecant function. So I'll put that right under here. C-O-S-E-C-A-N-T, cosecant. For cosine, the reciprocal function is secant. S-E-C is the abbreviation. And so that would just be S-E-C-A-N-T. And the reciprocal function for tangent is cotangent. Abbreviation is C-O-T, theta. And we'll put the word under it, cotangent. Okay. I think it's fairly simple to remember that tangent and cotangent are reciprocals to each other because the word tangent is within the word cotangent. So, I mean, that's really simple for me. What I remember and what I had told you at the time that we learned these is when I tried to remember which function is the reciprocal of sine and which function is the reciprocal of cosine, I simply remember that they don't start with the same letter. Right? So if you were trying to memorize this and you started pairing off secant with sine, well, they start with the same letter. So that would be an indicator that you're remembering that incorrectly. So what does this all really mean? Well, let's just think about what the word reciprocal means. So if I ask you what the reciprocal of 3/4 is, right, you would tell me that the reciprocal is 4/3, right? If I said, what is the reciprocal of -1/2? You would tell me that the reciprocal is -2/1, right? So I want you to notice something very, very important. Of course, reciprocals are different values. Of course, 3/4 is different from the value of 4/3. -1/2 is different from the value of -2. But what I want you to realize is that the sign does remain the same. So although the value overall is different, because of course we're flipping the numerator and denominator, we do not change the sign. So we're going to actually incorporate this rule for our original diagram here for All-Star Trig class. Because the reciprocal functions are going to follow the same rules as sine, cosine, and tangent. Despite the fact that they are going to have different values, they're going to have the same sign of their values, right? So for quadrant 1, when we say that all of the functions are positive, we also want to include all of the reciprocals, right? So the reciprocal for sine is cosecant. And the reciprocal for cosine is secant. And the reciprocal for tangent is cotangent. So going to quadrant 2, not only is sine theta positive in quadrant 2, but also its reciprocal will be positive as well. So we want to include that cosecant theta is positive as well here. Okay. Going to quadrant 3, not only is tangent positive, but also its reciprocal function will be positive as well. So that's going to be cotangent. And finally, quadrant 4, secant theta, the reciprocal of cosine theta, will also be positive. So now what we're going to do is we're going to just try to apply all of this knowledge from these 3 slides with an example. Okay. So you're going to make an XY axis, and we're going to be making a right triangle in quadrant 2. And we're going to put our theta nearest the origin. And we're going to start with a basic 3, 4, 5 triangle. So I'm going to put my 3 here, my 4 here, and my 5. But I'm actually going to do a little further labeling. Technically, I didn't label this side appropriately. See, what we actually want to do is we actually want to say that this side is -3. Now we know that length is not negative. The negative is not there to say what the length is. The negative is there to say what the direction is. It's going on the negative x-axis. So that's why we're putting the negative on that 3 here. The 4 will be positive because it is going upward along the y-axis. And the hypotenuse, actually, we always consider is positive. Now that I've given you a triangle with some sides here, now what we're going to do is we are going to practice, give myself a little more room, we're going to practice figuring out the values for all 6 trig functions. So let's pair this intentionally. So let's pair sine and cosecant together since they are reciprocal functions. And then we'll do cosine and secant. And then tangent and cotangent. Okay. And of course we'll use our knowledge of SOHCAHTOA to help us through this. Now let's try to figure out in our triangle what would be considered the adjacent side, the opposite side, the hypotenuse, right? So it's always in reference to the angle indicated, so in this case theta. So the side that has a length of 5, which is across from the right angle, well, the side across from the right angle is always considered the hypotenuse. The side opposite the given angle theta is considered our opposite side. And the side along, right here, right, we say that it is adjacent to angle theta. So this will be our adjacent side. So sine, based on SOHCAHTOA, is opposite over hypotenuse. So that would be 4 over 5. And cosecant theta is the reciprocal function of sine theta. So if we know that sine theta is 4 over 5, we know that cosecant is 5 over 4. Moving on to cosine theta. So cosine theta, based on SOHCAHTOA, is adjacent over hypotenuse. So that's going to give us negative 3 over 5. And secant theta is the reciprocal function of cosine. So we're just going to flip it. Notice we carry the same sign, we just flip the numerator and denominator. So secant theta will be negative 5 over 3. Tangent theta is opposite over adjacent, based on SOHCAHTOA. So that would be 4 over negative 3 for tangent. Now, by the way, I typically would just say negative 4 over 3 with the negative just sort of sitting more close to the numerator. I mean, these are equivalent. It doesn't matter where the negative sign is, so that is your choice. And cotangent theta is the reciprocal of tangent theta, so cotangent theta would be negative 3/4. Okay, again, notice that we're just flipping the negative, we're flipping the numerator and denominator, but the negative remains in the answer. And the last thing that I want you to notice is that our knowledge of All-Star Trig class can really help us to make sure that our answers are accurate. I'm going to erase some of these letters that I don't want you to look at right now. So I'm going to just flip back for a moment just so you can see. So based on our All-Star Trig class, we're working in quadrant 2 with this current problem. And notice that we said that in quadrant 2, there's only 2 functions that should be positive, sine theta and cosecant theta. And if you look at the results that we have here, it looks like our results are pretty consistent with that. Sine theta and cosecant theta are positive, which they should be, because we are in quadrant 2. And take a look, all of the other answers were not positive. So All-Star Trig class can serve as a really nice sort of like check system to make sure that the signs of your trig functions are appropriate. And we're going to do another one similar. So you're going to make an XY axis. All right, now we're going to focus on quadrant 3. So we're going to make our right triangle in quadrant 3. And we're going to insert our theta nearest the origin. Sometimes students have trouble drawing the triangles. When we did this in class, remember we had said that it's like part of a bow tie. So if you want to make your bow tie first, so that you can just bold over the triangle in whatever quadrant you're going to be working in, that might be easier for you. Okay, so now I'm going to review some other measurements of a classic right triangle. So 3, 4, 5 is very popular when you get to pre-calc and calculus. So that's the one that we just did. Another one that's really popular is the 5, 12, 13 right triangle. So that's the one that we're going to practice with right now. So we're going to put our 5 here, our 12 here, 13 has to go here. 13 is the longest side, it has to be the hypotenuse. Technically the 5 and the 12 I could have put wherever, because I didn't give you anything specific on that. Right? Now, we have to ask ourselves, do we have to tack on any negatives to any of these sides? And we do. We have to tack them onto 2 of them. We have to tack them on to this side and this side. Why? Well, because we're on the negative side of the x-axis, and we're on the negative side of the y-axis. The hypotenuse will never, ever be negative. So h, hypotenuse, is always positive. Okay, so we're going to do the same thing. We're going to figure out what all 6 trig functions are. I'm going to change the order. So we're going to do cosine theta, and we might as well pair it with secant theta, since they are related to each other. And then we'll do sine theta and cosecant theta, and then tangent theta and cotangent theta. Okay, so cosine is adjacent over hypotenuse, right, based on SOHCAHTOA. So our adjacent side to our theta would be -5, and the hypotenuse is always opposite the right angle, so that's going to be our 13. And therefore secant theta is the reciprocal of cosine, so it's going to be -13 over 5. And sine theta is opposite over hypotenuse, so the opposite side of our angle theta would be the -12, and the hypotenuse is 13, and cosecant is the reciprocal of sine, so that would be -13 over 12. Tangent theta is opposite over adjacent, so that's going to be -12 over -5, which you would want to reduce this one. A -12 divided by a -5 is just going to be a +12 over 5. And therefore cotangent is going to be the reciprocal of that, so it's going to be +5 over 12, right? And then as a very last resort, what you want to do is you want to check, and you want to check using All-Star Trig class. Now our triangle is in quadrant 3, right? So let's just quickly flash back to our diagram here. If we're in quadrant 3, then only tangent and cotangent have positive values. All of the other 4 functions should have negative values. So let's check out our results. It looks like that is working out. Tangent and cotangent wound up being positive values, and all of the other ones wound up being negative. So our check using All-Star Trig class worked out for us.